Good day, lovely viewers, and welcome to MathMarathon class. Okay, like I said in the last class, I said that our next class will be on the Venn diagram. And of course, we are here for Venn diagram. Now, the Venn diagram is very, very important in set. I think it's the hardest part of it to do, but it's also the part that helps the most. Because sometimes you might be given a large set of data, and for you to be able to analyze it or to see it clearly, you need a Venn diagram. Or sometimes in an exam, you might be required to draw a Venn diagram. So that's why it is very important that you know at least how to draw Venn diagram, how to use it, not just to draw it, but how to use the Venn diagram. So we're going to look into it. Okay, first of all, we're starting with the elements of a set. Now, when you have something like this, of course, this is the universal set U, and this is set A. And then you shade the inside. So this is what we call the shaded part. Is what we call the elements, the set of elements in A. That is set of elements in A equals shaded area. Shaded area. So this is when you talk about set of elements in A, this is how it is represented in a Venn diagram. Now, for this one, we have a circle like this. We have A, and then instead of shading the inside, the outside is now shaded. The outside is now shaded. Everything outside is shaded except the inner circle. And this is what we call A complement or A prime, or the universal set minus set A. This is how to represent it in a Venn diagram. Let's look at two sets now. Now, two sets. Now we have one like this, and then we have another one like this. And then this area is shaded. We have this as A, this as B. Okay, this is how it is represented. That is A intersection B. Is number one. Refer to the shaded area. Now, what if you want to get this area alone? Let's just label it as R, and this is Q. What if you want to get that portion labeled R alone? That's the other side. That is, it is called A intersection B prime. It's equal to that. A is the whole of this. But then B prime is something that is not in B, and which is this portion, the whole of this portion is not in B. So the intersection of A, whole of B, and the B prime, what is not in B, is this R. So if you want to get this R alone, this is A intersection B. Then if you want to get a B Q alone, that is still A prime intersection B is equal to what? Q. Now we want to get this area alone. A prime is everything that is not in, which includes even this side. Everything that's not in, everything that's outside, put the one in the universal set. Now, but what makes it this area is because it is the intersection of what is in B. So everything that is outside A intersects everything that is in B. That is this Q. So that's how to get this Q alone. Now let's look at union. When it comes to union, the set might be seen in three different forms. We ask to get the union. Now if you look at this one, this is A is a set containing another set. That is B is a subset of A. B is a subset of A. Now, if you want to get the union of this set, now, like we said, that the union of a set is everything that is in the two sets without repetition. That means union of A union B now is equal to everything that is in A. Union of a set is what is in the two sets without repetition. And if you notice, everything that is in set B, everything that is in set B is also in set A, because A has set B as a subset. So A union B here is equal to everything that is in B. But now coming to this one, the one at the center, A union B is equal to A plus B. A union B here equals to A plus B, because none is a subset of the other, and they did not intersect either. They are just two different sets in the universal set. So A union B was everything that is in this one plus everything that is in this one. So number of A union B is equal to number of A plus number of A plus number of B. For this one. Now let's come over to the other one. If you want to get to the union of these two sets, you have to observe something first. First is that the two sets you want to get the union intersect. That means they have something common between, and none is a subset of the other. So the union of that two sets now, that is A union B, is equal to everything that is in A plus everything that is in B, then minus what is common between them, that is minus A intersection B. You know why? Because since union of a set says there will be no repetition, now everything that is in A includes this place, because it is everything that is here, this first circle, which includes what is at that intersection point. The same thing plus everything that is in B also includes that intersection point, which is from here, everything that is here. Now, you notice that anything that is here has been counted twice. If it includes what is here, which is A, and also includes this place, it has been counted twice. Then, in order to remove one of it, because you can only count it once, according to the law of union, you don't repeat anymore. So, in order to remove one, that is why we put minus A intersection B. That is minus this intersection point, because it has been counted twice, and then to remove one, we put minus A intersection B. Therefore, number of A union B. Therefore, number of A union B is equal to number of A plus number of B, then minus number of A intersection B. There is something I need to mention, especially here. Here we're looking for union of two sets, but if it is intersection, if you're asked to get the intersection of a set that has another set as a subset, the intersection of this set A and B is everything that is in set B, because we're looking for something common. If you say that it is everything that is in set A, that means set B has some of the parts that is not common, which is not now intersection. But we're looking for intersection which is common in the two sets. Since B is a subset of A, so intersection of A and B is everything that is in B. But the union of A and B is everything that is in A, which is this one. Now let's look at three sets. Now we have three sets inside the universal set. Now first of all, let's talk about the intersection. The intersection of these three sets now, that is A intersection B intersection C is equal to that R. Now A intersection B intersection C is this. Now what of only A intersection B? This is equal to only A intersection B, which is we are looking for this T, and it is equal to A intersection B intersection C prime, which is equal to that T. When you get this T alone, and when you say A intersection B, you have included this R. But once you add the intersection C prime is everything that is outside C. That means eliminated this, you've removed this R. So everything that is outside C, then intersection what is in B and C, and it is this T. So that is T. Now, if it is only A intersection C, this now is equal to now A intersection B prime, then intersection C. This is only A intersection C, and which is the U region here. The intersection C alone is this variable. If you use only A intersection C, that means you've included this R. But once you add B prime, that means you've excluded the R. You now know that it's this point. And then the very last one is only B intersection C. And this is equal to A prime intersection B intersection C. And that is equal to B and C. That is equal to that S. That's S. Now, one last thing we want to look at is the union of three sets. The union of this set A is B, this is C. Now, the union of these three sets, that is A union B union C, is equal to, now remember what union says. Union says there is no repetition. Now, A union B union C is equal to A, everything in A, plus everything in B, then plus everything in C, then minus everything in A intersection B, then minus everything in A intersection C, then minus everything in B intersection C, and then plus everything in A intersection B intersection C. Now let me explain. A union B union C. That means you want to combine all the sets in these three elements, all the elements in these three sets, but we want to make sure that there is no repetition. Now, when we say everything in A, and A is the whole of this, that means A covers both the intersection of the three, the intersection of A and B, and the intersection of A and C, right? And now, everything in B also covers everything in the intersection of the three, everything in the intersection of B and A, which is here, everything in this, which is this S, plus C. C also did the same thing. It covers this one, covers this one, covers this one, which are not only the intersection of, which are not only for C, but the intersection of other. Now, in order to remove those repetitions, notice that for this T was counted what? Twice. This T was counted, it was counted when we said A, everything in A, and it was also counted when we said everything in B. Now, to remove it, we say minus A intersection B. That is to remove one of it. It was counted twice when we said everything in A and everything in B. This T was counted twice. And then in order to remove one, we say everything in A intersection B. So that means one of it has been gone. Right? Now, the same thing with A intersection C. A intersection. You notice that this U also was counted twice. When we say everything in A and everything in C, this U was counted twice. Then in order to remove it, we say minus A intersection C. Then the last one is this S, which is B intersection C. Everything, this S was counted twice. And then in order to remove it, we say B minus B intersection C. Then the last one, which is the most important, this R there. When we say everything in A, it was counted. When we say everything in B, R was counted. When we said everything in C, R was also counted. That means it was counted 3 times. But then, when we say minus A intersection B, you notice that R is part of that A intersection B. This is A, this is B. R is part of it. That means we've removed one of it. You remember we said it was counted 3 times. We've removed one of it. Now, when we also said minus A intersection C, this is A, this is C. And you notice that R is a part of that A intersection C. This is C, and this is A, and R is also part of it. That means we have removed two of it, remaining one. And we also said minus B intersection C, minus B and C. Notice that R was also counted here. B intersection C is this place and this place, because this is C, it covers that R, this is B, covers that R. So we've just, it's just like we've removed the thread that was counted when we said this, right? When we said A plus B plus C, R was counted 3 times. Then when we said A intersection B minus A intersection C minus B intersection C, R was removed 3 times. That means it's just like in the whole of this, we've not counted R. Now, in order to add it back, we now say plus A intersection B intersection C, which is this. R is A intersection B intersection. That is the intersection of the three sets. That is R. So this is it. It's very simple. That is why I said it's very simple. If it is explained well, it's very simple. Now, if it is also the number of elements in those sets, and number of elements in A, B, and C, just to put n in each of these. Okay, let me put it here. Number of elements in A union B union C is equal to number of elements in A plus number of elements in B plus number of elements in B plus number of elements in C, then minus number of elements in A intersection B, which is this one, then minus number of elements in A intersection C, and then minus number of elements in B intersection C, then plus number of elements in A intersection B intersection C. So this is it. If you're asked to get the number of elements in A union B union C, just to put number of elements in all these ones. So I hope you grab this when I explain it. It's very simple. Formula is very simple. Just everything in A, everything in B plus everything in C minus everything in the intersection of AB minus the intersection of AC minus the intersection of BC, then plus the intersection of all of them. So that is it for Venn diagram. That is just the explanation. Then our next class is solving problems that are related to Venn diagram. That is where we bring exam questions. WAEC, JAMB, SSCE. That's what we start solving in the next class. So thank you for staying through. Thank you for watching. Thank you for being part of our community. God bless you.